Hello guys, welcome to Limitless Coder and welcome back to our Java programming course. Yesterday we set up our development environment and wrote our very first Java program. Today we are diving into the fundamentals of Java, specifically variables, data types and typecasting. These are the building blocks of any Java program, so understanding them is crucial. So let's get started. Here, what are variables? In programming, a variable is like a container that holds a data. Think of it as a storage box where you can keep a piece of information inside the box. Okay, so the data stored in a variable can be changed or updated as your program runs. Okay, so in Java you will learn about variable declaration, variable initialization and types of variables, data types in Java, type conversion and typecasting. So move on to the next slide. We are going to declaring variables in Java. If in Java you declare a variable by specifying its data type followed by its name. Here is an example there. Int is a data type and count is a name. Another examples of other valid declarations are int age. Okay, in the this line of code declares a variable named age of a type int, which means it can hold an integer value. Right now the age does not have any value. Okay, it's just an empty container. Now we are moving to the next one, initializing variables. Okay, to give age a value we initialize it. This means we assign a value to the variable like this. Here you can see now the age holds a value of 25, this one. Okay, but there is no data type here and the next one, int age is equal to 25. We can also declare and initialize a variable in a single step. This is the meaning. Okay, and this is the example 2. This is more concise way to do the same thing. Okay, now we are moving to the types of variables. Here I can there is to initialize a variable you must assign it a valid value. Okay, you can combine variable declaration and initialization, same as thing. Float, we will see further these things. Okay, types of variables, there are three types of variables, which is local variable, instance and static variable. Local variable is nothing but a variable declared inside the body of the method is called local variable, and then instance variables is nothing but a variable declared inside the class but outside the body of the method, which is instance variable, and it is not declared as static. Even the local variable, it is not also declared as static. But in static variable, a variable that is declared as a static is called static variable, and it can't be local. You can create a single copy of the static variable and share it among all the instances of the class. Instance is nothing but there is a methods which you are using in the class. Now we are going to the program. I will show how the how we are going to understand the types of variables in Java. Okay, this is a class which is called which is named as A, and here we are going to declaring the static variable first. Static int m is equal to 100. So m holds a value of 100 and its data type is int. Now we are going to give the keyword of the name static. Okay, so it can be used in the class and it value doesn't change. Now in the method, now we are going to create a method. This void method is a method name. So int n is equal to 90. Here n holds a value of 90 and its data type is 90. Now here you can see you can use the variable only within that method. Okay, so in this variable it can be used only in the from this places to and then this one inside the method. Now for the instance variable it will be declared inside the main method. So int data is equal to 50. This is the types of variables, and there is a simple example. Now we are moving to primitive data types. Primitive data types are predefined and available within the Java language. So Java has 8 built-in data types called primitive data types, and these are the most basic data types and include int, float, double, character, boolean, byte, short and long. So let's start with the integer types. Java provides 4 different integer types, byte, short, int and long. The main difference between them is the amount of memory they use and the range of values they can store. Here you can see byte. it has 1 byte. Okay, for short it has 2 bytes. In int 4 bytes. For long it has 8 bytes. Okay, I'm going to the program. I will show. Here you can see for byte we can store only required, I mean in the range of -128 to plus 127. Here I am going to mention that. Okay, for byte is small number which is 127. Okay, for that -128 to plus 127, it is a range of byte. For short it is a medium number. I'm just mentioning it as a name, so don't worry. It has 32,000 and its range is -32,768 to plus 32,767. Now I'm going to mention the int. Int is a number, it's a regular numbers which is 1 lakh, and it is to -2 power 31 to plus 2 power 31 minus 1. Okay, for long it is a big number, then integer, so you can mention it as more, I mean mention it as L at the end of long value. This tells Java to treat the number as a long, so you can use the L at the end of long value. It has the range of -2 power 63 to plus 2 power 63 minus 1. Okay, it is the, in this example we can declare the various declare variables of different integer types. Okay, this long value, I mean here we can mention the L at the end of the long value. This tells Java is to treat the number as long value, so you can declare the L here. Okay, now we are going to the floating types. Floating types is next. We have floating types, float and double. These are used to store numbers with decimal. So float has 4 bytes, double has 8 bytes. I'm going to show how the float and double are initialized. Okay, these are the integer types. I'm going to for floating types. Okay, so here I'm going to mention the float, which is price. Okay, price is 9.99f. It is a single prediction 32-bit. Okay, and then next is double large price, 999.99, which is double. This is not prediction, this is precision, I think so. Precision. Okay, double precision, which is 64-bit. Okay, here the price is float and the large price is double. Notice the F at the end of float value, which tells Java it is a float value, so we are going to give at the end of float value as F. And other primitive data types, which is characters and booleans. Character and boolean, they are the textual data types. There are some points to remember about the primitive data types. All numeric data types are signed in a plus or minus. The size of data types remains the same on all platforms. Character data types in Java is 2 bytes because it is Unicode. Okay, Unicode character set. Unicode character set means it is a single 16 bit Unicode character. So I will show it in a program which is char a letter. Okay, I'm going to name it as letter, which is a. Okay, is single 16-bit Unicode character. Okay, Unicode character is nothing but Java supports internationalization. Unicode is a character set which covers all known scripts and languages in the world. So the word Unicode is here. Okay, and then these types are used for different purposes. For example, character is used to store a single characters like letters, while Boolean is used to store true or false values. Here I can show how the Boolean is used. Boolean is Java 1. Okay, true. Either it can hold true or false. Nothing than that. Okay. While Boolean is used to store only true or false values. Next, we are going to the consonants. These are the non-primitive methods. Non-primitive data types, which are includes classes, arrays, and interfaces. We can see in the further classes. In consonants, what is consonants in Java? Sometimes you may need a variable whose value shouldn't change throughout the program. For this, we can use a constant. In Java, constants are declared using the final keyword. Okay. For example, I have written here final int max speed is equal to 120. Okay. This line declares a constant named max speed. It is a constant named. Once a constant assigned a value, it can't be changed. By convention, constant names are written in all uppercase letters. Okay. Here we can declare the final keyword. In Java, constants are declared using the final keyword. Why we are using final keyword means it doesn't change the assigned value. Okay. And then another one, by convention, the constant names are written in all uppercase letters. So that's why we are using the uppercase letters in the name and the final keyword in the front. Now we are going to typecasting. Typecasting is nothing but in Java, typecasting is a process of converting one data type to another one. So there are two types of typecasting, which is one implicit and explicit typecasting. First one, implicit casting. Implicit casting, also known as widening conversion, happens automatically when you assign a smaller type to a larger type. For example, I will show all those typecasting and type conversion in a row. This is an example of typecasting, and these are the outputs of typecasting. Okay, these are the outputs of typecasting. I will show one by one. For implicit typecasting, we are going for a widening conversion, right? Widening conversion. So this is the program. I will create another new one. Okay, new program which is hello world. You can write here. Okay, there is a class called hello world, and I have declared a main method. Then I'm going to write int a is equal to 10. Now float f is equal to a. Okay, implicit typecasting is nothing but uh, widening conversion. It happens automatically. Automatically when you assign a smaller type to a larger type, which is implicit casting, other way of widening conversion. Okay, I'm going to the program. First I'm going to print the value of a. Okay, start out. Okay, then I'm going to print the value of f. Here you can see the output will varies because we are giving the integer value as 10. Now we are going to convert as a float number. Okay, now you can see how the code works. Yeah, here First a I have printed, a is an integer number, so it has 10. Okay, it is 10. Okay, now I'm going to convert a into a float number, so it will provide a dot 0 because float and double used for decimal numbers. This is widening conversion. And the another thing is explicit casting uh, or narrow conversion, we can say like this one. Okay, is when you convert a larger type into a smaller type. This needs to be done manually because there is no risk of losing data. Narrow conversion is nothing but, I will show it in a program. Okay, for typecasting, this is explicit casting is narrow conversion. Now I'm going to declare float value, which is float value f is equal to 10.5. F, why we are giving f means Java it tells the Java it is a float value, so we are giving the f at the end. Okay, now I'm going to convert this float number directly to the integer. You can see what will happen. It will have some error because there is a compilation error while doing this one. Here you can see, yeah, the compilation error cannot convert from float to int, so that's why we are using the typecasting in this one. So how to typecast the float number to integer? This is the typecasting. Int f. Now we are going to print the f first, then I'm going to print the a first, a, and the next. I'm going to run this program. Here you can see what is the float number, 10.5, but I have converted here by using the typecasting. This explicit, it can be converted into the integer number. The decimal part is removed. Okay, this is the another part of typecasting. Now I'm going to move next, which is explicit is also done, and Java is also allows you to convert string to numbers and vice versa. Okay, for example, you can use integer.parseInt to convert a string to an int and int to string. Okay, now we are going to change this one. Okay, I will show how it was working. Same, I'm going to take this one, then I'm going to mention string. String is also a data type declared within the double quotes. Now int num, this number. Okay, integer dot parseInt. Okay, this is string number. It converts string to int. Okay, going to print num, will convert it as an integer. So I'm going to run the program. Yeah, it is 1 2 3. Okay, nothing but this string value is converted here as an integer, and the integer will be printed in the console. Okay, now I'm going to convert the integer into the string. Nothing but int another number is equal to 456. Okay, now I'm going to convert the integer into the string. So we're using the string str is equal to string dot value of another number. Okay, it will convert int to string. Now you can see how it was working. Str, we are going to print the str. I'm going to run this program. Here you can see there are two numbers. Which one? First one is string to integer and second one is int to string. Here you can see 456, it will be converted as a string. These methods are useful when you need to handle input or output data in different formats. Okay, that's why we are using this one. Then next I have some of the programs here after this one. This is also the same thing, why we are typecasting this one. Okay, and it will be changed int converted to byte, double converted to int, double converted to byte. Okay, nothing but here there is an examples of variables. I have done a widening, narrowing, and some program. Okay, widening and narrowing is completed. I will show how to add the two numbers in Java. Okay, here it can be removed. I'm going to declare int a is equal to 10. I need three variable. So adding two variables and I have stored it in another variable. So I'm going to initialize another variable which is 15. Okay, then I'm going to save it in a C, a plus b, adding the a and b and stored it in a C. Now I'm going to print C. I'm going to run this program. 25 is the answer. Okay, this is Java variable examples by adding two numbers, and I have shown widening also, widening and narrowing typecasting, which is implicit and explicit, which was done. We are going to the overflow, how we are do the overflow of this one. This one. Okay, overflow program. Okay, now the class was created and the main method was created. Then I'm going to initialize a variable which is a is equal to 130. Next, I'm going to convert integer to byte number. Okay, so byte b is equal to, now we are using the typecasting of byte. Then I'm going to print the a first, then I'm going to print b in the second row. Okay, b in the second row. Now it will show some values and I will explain how it was done. Right. Okay. So that is an output which is 130 is the a. A stores the value of 130 and it will be displayed here. But after typecasting, after we converted the integer to byte number, the number is mismatched, which is minus 126 is not the answer. This is the reason in Java the byte data type is an 8-bit signed integer, which means it can hold the values from minus 128 to plus 127. When you assign an int value 130 to a byte variable, the compiler performs a narrowing primitive conversion, which involves truncating the higher order bits of the int value to fit in the 8-bit byte range. Okay, in this case, the binary representation of 130 is binary representation. Okay, for 130 is 10000010. This is the value. Okay, and the value is truncated to fit in the byte. The result binary representation is same as this one. Okay, which corresponds to the decimal value is minus 126 in 2 complement representation. Okay, then this demonstrates that the assignment of an int value to a byte variable can result in an overflow leading to an unexpected value can be being stored in the byte variable. So this is the thing why the minus 26 came, why the stored value is not available in the byte variable. Okay, byte the b variable. Okay, this is the thing. and we are going for a adding lower type. Okay, we are going for the adding lower type. This adding lower type, I'm going to cancel this one and clear this one. Now I'm going to type byte b is equal to byte a is equal to 10, and then byte b is equal to 10. Then I'm going to adding this one, adding this one. Okay, byte c is equal to a plus b. I'm going to run this program. Just wait, I will print the C. Is it work or not? By sure it will return, I mean it will give the compile time error, because a plus b is equal to 20 will be an int. Okay, for because while we converting this thing. Okay, sorry, there is a mistake, right? Now it will give the compilation error. Now you can see there is a compile error. I will proceed there. Cannot convert from int to byte. This is the integer value. Okay, now it cannot be converted into a byte value. So how we can do this problem? Going to changing this one. Going to casting the byte by using byte and a plus b. Now it will give the value of 20. Now you can see, yeah, this is the adding lower type, which is we are going to converting the integer to byte. Okay, without casting we cannot do the uh, adding numbers. This is the program of adding lower type, and today we are and these programs are uploaded in GitHub too. You can go through it, and that's wraps up our lesson on Java fundamentals. Today we are learned about variables, data types, constants, typecasting, and type conversions, and some examples programs of variables. These concepts are essential for writing any Java program, so make sure you practice them. In our next lesson, we will explore operators in Java, which will allow us to perform calculations and more complex operations. And don't forget to like, subscribe, and hit the notification bell to stay updated. And if you have any questions, the floors are open. Please ping me in the comment. What uh, what is the questions you have? What are the questions you have? Okay, so see you in the next lesson, and thanks for watching, guys.